Hi everyone, welcome to the fourth video of Module 4, and here we're going to talk about NumPy arrays. We'll understand that how you can create your own NumPy array, and then how to check the data type of that array, dimensions of it, and then finally how you can check the shape of that array that you have created. So let's get started. Now let's go ahead and start using NumPy first of all, and later on we'll start using matplotlib, okay? So with the help of NumPy, the first thing that I'm going to show you is to understand that how you can convert a list into an array. Right? Convert a list into an NumPy array. How? Let's go ahead and look into that. I'm going to say that list is equal to, let's say, some bunch of some random stuff that I'm just giving in. All right. After this, if I want to convert it into NumPy array, what do? I simply go ahead and use the functionality of NumPy, that is np.array. Inside it, I can give some of the object. As you can see, I have not done anything. I have just created np.array. I have created that kind of parenthesis and waited for a few seconds. And this is the whole short documentation in front of you. It tells you what type of input parameters it takes. All right. All of this information is there in front of you. You can surely go ahead and explore this. But I'm going to tell you that how you can simply go ahead and do this is to pass in this type of a list right inside it. And just call it, let's say, ARR. And now over here, I'm going to print what is the type of the list. And after this, I'm going to print what is the type of this array. And let me go ahead and run this code. You can see that the first, that is like, what is the type of this list? It's list. Then what is the type of this array? You can clearly see it's NumPy ND array. It's NumPy n dimensional array, right? Now, if I want to check what is the dimension of the array that I have created over here, what is the dimension? For that, you can go ahead and simply, but before that, I'll just go ahead and comment this kind of code. Create list of some numbers. Okay, after that, I'm going to say that convert that list into an array. By the way, these are some data structures and it serves some different way through which you can deal with data. But I won't go into the data structures part in the theoretical part. Instead, I'll just focus on how you can create them and how you can start using them. All right. So yes, this is a way through which you can convert a list into an array. For example, let's say if I want to create a 1D array. It's done in pretty much the same way. I'm going to, let's say, call array1 over here and say np.array and just create 1D array by passing in this 1D inputs. For example, 1, 2, 3, 4, 5, whatever it is. I can print this array1. It's going to pretty much look like list only, but it's not actually a list. I've proven this, right? I've just said what is the type of this ARR1. It's actually going to be NumPy array, right? You can see that it's a NumPy array. You can do a lot of mathematical broadcasting and all these things you can do with the help of NumPy, which you cannot with the help of list. Okay, so that's a major difference. Like if you have to do mathematics with this array that you have created, it's going to be simple as compared to if you have to do it with the list, it's going to be a little bit challenging. All right, but yes, it's not that lists cannot do it, but it's a bit big approach that we take over there. So it's always better if you are going to deal with some kind of mathematics with this type of arrays, you go with NumPy arrays. All right. So yeah, that's how you're going to create a 1D array. Now, how do I exactly check what is the dimension of this array? Check. What I'll do is I'll also give some of the heading over here. Check dimensions, shapes. Check dimensions and shapes of the array, right? Let's go ahead and do this. So let's check dimensions first of all. I'll also do one thing more, that is check data type, dimensions and shapes of the array. So first of all, let me check the data type. Check data type of ARR2 or ARR1. Right? How can I do this? So this type that I have given is not actually the data type of array. This is like, what is the data structure? It's a NumPy array basically. We are having that it's an array. But now this array is filled with what type of data? Is it an integer? Is it a float? Is it a string? What exactly does it contain? So for that, what I need to do is I simply need to go ahead and simply mention that whatever is the array, I do .d type. Okay, so this d type is automatically having this value stored, that what type of data type it is having. If it's an integer, which is in our case, it's going to give you an integer. If it's a float, it's going to give you a float, and whatever it is respectively, it's going to give you the output. Clearly we can see that it's integer of type 64, right? This is the output that we have got by checking the data type. Now if I want to check the dimension, if it's a 1D 2D, what it is, so how we can check the data type, I mean how can we check the dimensions of ARR1? I can simply say ARR1 dot ndim. This is the type of command I need to write, and simply run this. You will see that the output is 1. It means it's a 1D array. Okay, it's a simple one-dimensional array where you are having a row with how many columns? You are having 5 different columns. It's a 1D array basically, where we are not actually having row and columns. Rather, you can just call it as a row vector. Simple as that, right? If you have to convert this into a row, comma, column type of thing, like one row with 5 columns, it's called as 2D array. I'll just show that to you over here. First of all, create a 2D array with 1 row and 5 columns. How can I do this? I can again create, let's say ARR2 is equal to np.array. Now I'm going to say that this is 1 2 3 4 5 again, but this is a row vector. On top of that, I'm going to pass one more this kind of square brackets, and now this square brackets is indicating that this is the first row, and whatever elements are present inside this is going to act like a column. So there are 5 columns, right? So I can also verify this. I'm just going to run this. I can also check the dimensions for ARR2. So ARR2.ndim is what it's going to be 2. It's a 2D array. But now what is the shape of it? It must be 1, 5. So if I just go ahead and check this very quickly, because see, whenever you create an array and if you go ahead and check its shape, it will be in the format of row, column. So I'm going to do that. Check the shape of both ARR1 and ARR2. What's the difference between them? Let's go ahead and check it. So ARR1.shape, let me just go ahead and print it. Print ARR1.shape. Just like that. I'm also going to go ahead, copy this part, paste it over here, and convert this to ARR2.shape. Let's see what's the output. In the second one, because it was a 2D array, it's giving you this row and column, 2-dimensional data. Over here, because it was a row type of an array, like a row matrix or row vector, whatever you'd like to call, it's telling that it's an element with only 5 values in it. That's what it is indicating. So I hope this is clear to you, that how you can go ahead and check the shapes. What is the difference between a 1D array and a 2D array? Just like this, if you want, you can also create a 3D array. But I'm not going to go into the 3D array. Rather, let me just try to create a 3x3 array of the values in between 1, 2, 3, 4, 5, 6, 7, 8, 9. In between 1 to 9 basically. Alright. So create a 2D array of shape 3x3 with values of in between 1 to 9 and must be float. How can I do this? I can go ahead and say that np.array, and after this I can create one row inside this. This is 1, 2, and 3. After that I can create another row, but before I create another row I need to give a comma over here. And now this is be what? This will be 4, 5, 6. After this there is one more comma. This is 7, 8, 9. And now we are having, as you can see, there are 3 different rows that we have created over here. And in all these rows, you can see that there are 3 columns. So it's a 3x3 array. But now I want to convert the data type of it to float. There are 2 ways through which I can do it. Manually, while creating an array, it gives me this option to provide the data type. If I say that d type is equal to, let's say for example, np.float, it's going to convert it into float, right? If I tell np.int 8 or uint8, unsigned 8-bit integers, even that is possible. So that's one of the way. Let me just also give it in this way. When this is fine, np.float is also fine. So let me just first of all save it in ARR3 is equal to this. Okay. Let's give a tab over here, tab over here. Yes, I guess we are all set. Let me run this. Now check the shape, of it over here of ARR3, also n dimensions, as well as, let's say for example, data type, right? So print ARR3 dot shape, print ARR3 dot ndim. Just try to guess what will be the output. Just try to do that. And then ARR3 dot dtype. Let's see what are the outputs. I'm going to run them. You can clearly see that this is a 3x3 array. It is having 2 dimensions because of that row comma column. And then the data type of it, because we have given this float, it's giving us over here by default float 64. Okay. If I want to convert this into, let's say for example, float 16 or float 32, I can do this with the help of np.float32. Okay. If I run this code, hopefully it's going to run. It's not going to give me any kind of error. Yes, it's working fine. I'm going to run this code, and you can see that now the data type is float32. So yes guys, that's how you can create 1D array, 2D arrays, and also check its shape, check its dimensions, data type, and whatnot. So that's it about this video over here guys, and I hope that you are now comfortable in creating this kind of NumPy arrays, and then how you can check its data type, dimensions, and shapes. Now in the next video, I'll be showing you some more ways through which you can create these NumPy arrays. So I'll see you over there.